Greetings, I'm one of the Group O members. I'll be presenting our work on building and evaluating a distributed machine learning using a linear regression model which was introduced by Francois Galton and Hal Pearson. We will also be using a housing data set which have nothing but 10,000 sample size. As we both know, machine learning models are traditionally trained on a single machine, which can limit the performance due to computational power and memory. So as a group, for us to overcome these limitations, we came up with the idea of distributing nothing but the workload across the multiple workers where they'll be sharing the data. Yes.
So the system that we are using the stochastic gradient descent algorithm with the learning rate of 0.01 implemented in the parameter server architecture, which is a classic way of training neural networks by distributing the works to the workers. So the parameter server can run in one machine. So this is the machine that we'll be using to distribute the weight of the current model to the workers. So as we can see here, we have distributed the weight of the models to the workers. So and then the workers will then compute the weight and then produce a gradient, as it is shown that it is now sending the gradient after computation, and then it sends back to the server, and then the server will compute both of the gradients from the workers and then use it to update the model.
I'll be presenting the problems and solutions. The first problem that we encountered was the server connecting with the workers because of the security, because of the security risk due to connections. Because at some point we had to make the security part of the server public in order to acquire data to generate samples. But the solution to that was that we created a code that generates an IP address using the Wi-Fi. We created an official pod in order for the PCs or the workers to join each other. And so the second problem that we encountered was that when the sample size is smaller, it takes the server not long to execute them, meaning that it takes time for the execution part because the server will distribute the small sample, and then it will take time for those workers to actually execute and bring back the results to the server. So the solution to that problem was that we increased the sample size. Thank you.
The results show that in distributed training, we achieve faster losses and reduced losses compared to single machine learning. While single machine learning setups shows gradual improvement, the distributed system demonstrates more efficient convergence over epochs, and the training significantly reduces the time per epoch. And significantly, machine training takes approximately 90 to 150 milliseconds per epoch, whereas distributed training reduces the time around by 50 to 70 milliseconds. This confirms that parallel computation improves overall performance.
In conclusion, the project successfully demonstrated that distributed machine learning can significantly improve training efficiency. The parameter server architecture enables scalability and coordination between workers, and also future improvements could include adding fault tolerance, optimizing communication, and using real-world datasets. Thank you.